My friends, welcome to another tutorial exclusive. In this video, we are going to convert from logarithmic to exponential, all right? So now, instead of going from exponential to logarithm, let's say I give you the inverse function. Let's say log base 2 of 16 is equal to x, and I want you to convert back to exponential functions, back to an exponential model. Well, you look here, remember this little 2 told us the base, right? This told us that this was the inverse of 2 to the x. This on the here is your input. Okay, it's what we plugged in, 16, and this x on here is your output. Okay, this is a number on the outside. Don't get mistaken just because it's x to think, oh, that's the input. No, is it on the inside? Is that what you would plug in? And then what's on the outside? What is the result that you get after plugging it in? So the number on the outside is generally going to be your output always. Okay, so we know this is the base, so we just write the base 2. We know we have 2 raised to something is equal to blank. Well, let's start off. Let's start with our input. Our input 16. Well, when you do the inverse, what do you do to your inputs? Well, the inputs become the outputs. You switch the x and the y's. The input becomes your output, so that goes on the outside. This is your output, so that now is going to become your input, right? Right there. So we get 2 to the x is equal to 16. And we have actually solved this in the previous video. That was 2 to the 4th. That's what gave me 16. All right, let's go ahead and do another example problem. Maybe something a little more challenging. Log base x of 10 is equal to 4. All right. Well, again, maybe if it's helpful, let me label. This right here tells me the base. This tells me the input. And this tells me the output. Well, so I'll start off with my base, x. And I'll do equals, okay, and we know it's going to be question mark, all right? Well, we can tell if this is my input, that's got to become my output. This is my output, well, then that's got to become my input. So I'll get 10x to the 4th is equal to 10, right? Now we can actually solve a problem like this. Kind of cool. We go from logarithmic to exponential, and then we can solve this. Well, this is to the 4th power, right? And so that means it's going to make a U shape, which means we're going to need our plus or minus. So we can raise both sides to the 1/4. Okay, or do the 4. You could put the little notation 4 and do that kind of square root. All right, so we get x is equal to plus or minus 10 to the 1/4, and then we could just use our calculator to solve that, and we would be done. All right, I won't solve it because that's not the point of this video, but that's something that you could do. All right, let's go ahead and do another problem. Let's say we have log, we'll put an x, let's do 3 is equal to 9. Okay, again, to label, this is my base. Actually, let's write it like this. 9 is equal to log base x of 3. All right. Well, again, this is your base here. All right. Now, even though the 9, I wrote it over here on the right side, I could put it on the left side. It's just a number on the outside, right? This is my output. And the 3 doesn't matter. It's on the inside of the parentheses. It's what was plugged in is your input. So to rewrite this to logarithmic form, your base is x. Your input becomes your output. So that goes on the outside, so 3, and your output becomes your input, so it's x to the 9th equals 3. Now, because it's to the 9th power, that tells me we're going to make a saddle shape, or as you guys like to call it, a snake. All right, either way, we know it's not going to create this u, so we don't need a plus or minus. To solve this, we just raise both sides to the 1/9, and we get x is equal to 3 raised to the 1/9. I don't need that plus or minus because it's not going to make a u shape. All right, let's go to another example problem. Let's say we got 2 times log. Let's use 2 of 16 is equal to 32. Why not? Okay. Well, again, this 2 right here tells me my base. This tells me my input. And this tells me my output. Okay. Well, look at this 2. What does that 2 tell me? It's kind of in the way, right? So because it's in the way, I don't want it there. I want to get rid of it. Well, what can we do to get rid of the 2? Since we see a multiplication sign, we can divide 2 to both sides. These 2 cancel. I'll be left with log base 2 of 16 is equal to, well, 32 divided by 2 is 16. Okay, if you want to, you can go ahead and label what you want. The 2 is your base, this is your input, and this is your output. All right, well, let's write our base, 2. All right, equals blank, right? And we know we're gonna get something over here. Well, your input becomes your output, so that goes on the outside, and your output becomes your input, which goes out here. Well, look at this. 2 raised to the 16 equals 16. Well, that doesn't make sense because we know 2 to the 4th, right? 2 times 2 times 2 times 2. That's what gives me 16. So we can conclude, after converting this to exponential, this is why it was helpful to convert it. We can conclude this is not possible. Okay? This is non-existent. I don't even know how to spell that. So let's just move on. Not possible. So very nice to convert it, and we can see something we maybe wouldn't have been able to see otherwise. We'll just do one more example problem. Log base of x to the, let's plug in 10 is equal to 27. All right. Well, your base is x, and I'll do this quickly. 27 is your output because it's on the outside. So 10 to the 27 is equal to 10. Now I could solve this, just raise both sides to the 127. Because it's odd, I know it's gonna make a saddle. We don't need our plus or minus. So 10 raised to the 1 to the 27, and we are done. All right, let's do one more. Okay, let's go ahead and do this problem right here. Log base 2, okay, of 1 is equal to x. All right. Actually, no, let's change that up. Log base 2 of 2 is equal to x. Okay. All right, if we go to do this problem, well, your base is 2, so you get 2. Your x is your output, so that's got to become your input. So 2 to the x is equal to, well, this is your input, so that becomes your output. 2x equals 2. Well, x has to equal 1 then. Boom, done, and we are golden there. All right. Why not try one more? Let's try this right here. Let's do log. I'm just gonna put a little e there. Log base e is equal to 3x equal to 21. Well, no, you know what? Let's put 21 in here, and let's put 3x over here. Cool. Let's just complicate it. All right. Well, again, this is your base. This is your input, and this is your output. So let's start with our base. E to the raised to some power is equal to blank. Well, this is your input, so that's got to become your output. And this is your output, so now that has got to become your input. So we should get e to the 3x is equal to 21. All right? That's how we convert going the opposite direction from logarithm to exponential. All right? You have yourself a fantastic day.